The dark side of the Rust language. Are you ready for this one? Rust is an amazing language. If you follow my blog activity and you know me in person, you might know I'm really invested in Rust in the last 12 months and also blogging a lot about Rust. Now, I want to do something different. I do not want to paint a rosy picture of Rust. I do believe trade-offs matter, and you only know something true when you know the cons. Yeah, I agree with this. This is good. Okay, this is a good start. This is a good start. There are some problems I will expose in this blog, and not related to Rust only, but related to the fact about two other factors. A, new languages. B, Rust has a plus 10 years, however, still not mainstream, and I consider it a new language. And B, a new paradigm/approach. Everything you deviate from standards copium, you will face resistance. I saw it happens. I saw it happens a lot with other languages like Scala and Clojure. These problems happen in Rust, but I want to make it absolutely clear they are not unique to Rust. So let's get started. Let's start with the good things. Okay, what are the good things? Sorry, I was having trouble reading that. I don't know what happened. I'm not sure what just happened there, but I couldn't read there for a second. The great things about Rust. Before talking about Rust benefits, you might want to talk. Let's see. You might want to take a look. Okay, maybe I'm not the one having, maybe I'm not having the hard time reading. Maybe it's just some of the words in there are incorrect. You may want to take a look into some of the blog posts I made about Rust. Rust, the language of the future, rich type system. I love the type system. Rust and Java interoperability. Why would you write Java? Rust service and Kubernetes is only 3.5 megs. Let's go. Building a microservice in Rust. Let's go. Axum/Actix. Now let's talk about Rust language benefits. Live. Rust is a live language. It has a community, tech events, new ideas. I mean, we all know about the tech events, am I right? And libraries are flowing and popping up every single day. I would argue this is one of the most desirable properties of a language. You want to be where the innovation is happening. Interoperability. Rust plays well with pretty much all other languages. I thought this was the opposite. I thought Rust is not that great. I thought the interoperability with C++ kind of sucks with Rust, because of all the issues it has to do with being from safe language to inherently unsafe language, right? Glazing. I thought this was like one of the reasons why Zig is so amazing is that it just is much better at that, right? Anyways, it's easy to invoke this language from Rust and vice versa. For this reason, Rust is really great for embedded systems and IoT. I think Rust is really great for IoT or embedded systems, because if I'm going to make some sort of system that could accidentally crush my hand, I would rather have it crush my hand because I'm a horrible programmer, not because I had some sort of like oopsie daisy in my programming because I'm a dum-dum, right? I would rather have it that I actually made a thing that just is like the hand crushing module and I accidentally crushed my hand. Not because I was just like, well, I thought I was writing good C, but it turns out I pointed to the wrong thing and just, yeah, right? Easy to read. Rust code is obvious. This is very untrue. I think Rust code is not easy to read. Once you get beyond a simple application, Rust code becomes excessively hard to read. You have to really, 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 really know what you're doing to read Rust code, right? There's definitely an arc of expertise that's required in Rust. It has a very deep, deep side to it, and I love that about the language. I love it a lot about the language, but it's not obvious. It's not easy. I don't think the syntax is weird. I think the syntax is different, right? And that's a big thing, is that just because syntax is different doesn't make it weird. The first time you looked at syntax, the first time you learned some other syntax, it was weird, right? I started off in PHP. There's like colons and dollar signs and all sorts of shit everywhere. Like, that's weird, but it felt normal. And then when I got done with it, it wasn't normal anymore. You know what I mean? It's very easy syntax and therefore very easy to read code. The ability to easily read code is important from maintenance perspective and for learning. Again, I just don't think that's a real thing. Functional vein. Rust allows functional programming. You have lambdas, optional, map, find, filter, and much more. Functional programming is a really great paradigm, and modern languages need to embrace it, at least partially. I think that's one thing that Rust has done really, really well, which is like it's functional light. Like, it has most of the things you'd ever want. You know what I mean? Memory allocation. Rust really forces you to think about memory allocation and memory management. I actually feel it's quite the opposite. I feel with Rust, you don't think about memory at all, right? Like, ever. You just do it. And when something's slow, you're like, I'm probably allocating on the heap. I mean, there's like a simple rule. If you put it in a container, it's probably on the heap. If it's not in a container, it's probably on the stack, right? If it's in a box, it's on the heap. If it's in an RC, it's on the heap. If it's in a ref cell, it's on the heap, right? Like I find that you think one reason why I like Rust is I don't think about memory allocations. And that's what I like. Zero cost abstraction, I love this too because iterators they disappear when you compile. Another great Rust capability. Several languages have great syntactical sugar and features. However, often using the abstractions are slow compared with the standard features. Yeah, I love this. So I love that where iterators, they don't cost, right? Fantastic. Rust library variety. Rust has a great variety of libs and ecosystem. Yeah. Only 35,000 libraries. I could get 35,000 libraries in NPM by installing LeftPad. Okay, you think that's amazing? Please. All right. Speed. Rust is super fast, faster than Java, Go, C++. Okay, it's not faster than C++. I would even argue that it's hard to make it faster than Go. I would say that you have to be pretty slick at Rust to make it faster than Go. So Rust is only slow compared with C. No, you can the statement doesn't make any sense. Compared with high-level languages like Java, .NET. .NET's not a language. Go, Python, Ruby. Rust is super fast. Well, Ruby's technically, I think I could beat Ruby in a foot race. Rust is super fast and much better than these languages in a sense of speed. This means doing less with more, saving costs if you're running on the cloud, and better user experience. Safe. Rust is also super safe. It's true, as long as you don't use the unsafe feature. And even then, it's still pretty safe. This is one of the main advantages of Rust. The compiler is really your friend and catches many things. WebAssembly. WebAssembly is the future of the web. I sometimes deep down inside my inners, when I hear the term WebAssembly is the future of the web, I also think about 2023 is the year of the Linux desktop. You know what I mean? Do you ever feel that? Do you ever feel that by any chance? You guys call it a flag on the play right now? It could. And the implementations are in Rust. This is another very attractive point of the language. I do agree that it is, I think, the best WebAssembly language right now. Small binary, small footprint. Is that true? I don't know the binary sizes. I've never compared them. Rust is not a memory sucker like Java. Suck my memory, Java! Rust generates a very small self-contained binaries, which are usually great for containers like Docker and cluster managers like Kubernetes. Great for concurrency. Rust has a strong, is also strong. I don't always think Rust is great for concurrency. It's great for correctness. Don't get me wrong. It's great for correctness. It's not always it's not a dynamite at concurrency, right? Because one of the problems that I don't like about Rust is that there's things you can do in C++ that are kind of unique because you have this whole separation of mutex, whereas often the mutex contains a piece of data. And so you'd have to do something kind of silly to make it so that you could have multiple parts be mutex, but not all parts be mutext, right? It's kind of I don't know. I always find it like a kind of an interesting argument. I don't think that it's fantastic for concurrency, but I think it makes it really easy to do the right thing, which in most cases is great for concurrency, right? For the most part, that's what you want. Better than Go? I wouldn't say it's better than Go. I would say that it's different than Go. Go, you run into the same problem, but you run into that into any language, which is you try to read and write to the same resource, right? That's a very classic thing. And so they have mutexes. We can mutacy. And so it's not, but the difference is that I can also just hand you something, and if you're in a different thread, I don't have to think about it, right? Here's the thing, it doesn't need to be behind an arc mutex, so when I pass it, I don't have to pass something that has this atomic reference counting, then on top of it, I have to unlock it to use it, right? I can just give you something, and you can use it. There is a performance advantage there to just not caring, right? And so it's not a 100%, right? It's not just it's better. So that's what I mean. It's there's trade-offs. The thing about Rust, though, is when you cross that thread boundary, you are guaranteed to be doing it the right way. And so, yeah, correct is better than fast. So that's the one nice part, is that you are forced to do it the right way, but you may accidentally write something that's slower. Are you still learning Zig? Yeah, I wrote a little bit of Zig yesterday. Small market. Currently, there are a few companies using Rust. Yep. The dark sides of Rust. Okay, so this is a real thing. Therefore, few programmers and few job offers. I do believe the market size will increase. I do too. But if you need massive number of developers now and cannot afford their education, Rust. So I disagree with this point. I think that if I tweeted right now, I have 3 open positions, I could fill it within the afternoon. Right? Like, I think there's there's a larger, hungrier crowd than the positions that are available. I don't think it'd be hard at all to hire Rust devs right now. Too many strings. Rust has an issue with strings. Rust has 6 string types: string, stir, C-stir, C-stir, OS-stir, OS-stir, which makes it complicated and confusing. Some functions return stir. There's also a cow string. Where's this cow string? Moo, right? You have that 2 glossy UTF-8 or whatever it is. Anyway, some functions return string. I might just be wrong. There's also path buff. Don't forget path buff, which is really just a string. You know, it's a string that allows for that non-UTF-8 encoding just for this one little tiny little thing. Copy on write. Copy on, Orville write, yeah. Moomy daddy. Wow. Slow compilation, yep. This is true. This is actually a real problem, though it's not a real problem. It's both a real problem and a non-real problem. As you have 200 plus dependencies, you'll see compilation become super slow. Everything, or almost everything is statically linked, which makes compilation slow. You have a lot of outdated libs in your file system. Okay. IDE support is not ideal. I'm VS Code. I am VS Code is the best option so far. It really isn't. So this article must be older. It must be older because Rust Analyzer is fantastic. Right? It's fantastic, right? So I'd say Rust Analyzer might be one of the best. Might be one of the best on the markets. Honestly, it's one of the best language servers I've seen yet. Libraries, low maturity. Several libs are incomplete and immature. Often you find poor documentation and documentation that is not up to date. This makes using a library always an adventure because you need to look at the source code. And guess what? The source code's not always all that easy to look at. Let's see. Rust is not for beginners. Yep, this is true. I don't know about that. I'm curious if this is true. I guess because I can never relearn for the first time. Is Rust not for beginners? Like, if you had no concept of programming, ownership and borrowing, I thought ownership and borrowing was really straightforward. Like, I read one small version of what it does, and it makes perfect sense, right? There's the thing. Then there's things that refer to the thing. I don't know. I didn't find it very confusing at all. And so I'm a beginner and I find it very easy. I'm very curious about it because in the sense, like, if you knew no other paradigm, would Rust be hard to learn? Would it be harder to learn than, say, C? Ownership and borrowing were easier for me to grok than scope. That's super interesting. C is simple. C is simple, but it's also hard. Right? It's both simple and hard. C, to just to like know what C can do, it's very, very simple. But to do something in C and to actually get experience is really hard. Right? Pointers are difficult to grok, right? So like there is that whole aspect. Like you could learn the syntax in an afternoon, but to know how pointers work, why you'd want to use double pointers, a const pointer to a const versus a pointer to a const versus a const pointer to a value, right? Like what's the thing going on there, right? There's a whole bunch of stuff there. The compiler is very helpful. Yep. C is easy to behave undefined. Yes. Melky just posted your nipples on Twitter. Nice, Bertrand. Let's get those nipples up. Also, shout out to Melky. Come on, Melky, give me them nips. Where's this nips? Is it right here? Nope. Where is it? Where's my nipples? I don't see my nipples. Link it or it didn't happen. Okay, let's go back to this thing. Rust is a great language, and I believe Rust will grow a lot in the new years. Documentation, library maturity, jobs, engineers, tooling support issues tend to get fixed. However, borrow and ownership is not going away, so you'll be required to learn. Yeah, I really and truly don't think. Look at those nipples. You like that? I took a picture of myself. I've been getting in shape, okay? People asked for it, and I gave it to them, okay? This is what 37 looks like, okay? Thirst trap. I'm sorry. You know, I actually am always a little embarrassed to know that there's a naked photo of me. Look at that. Look at that one pack. I have one pack. I have a singular item called a stomach. See, would you call async race conditions race conditions? So it depends on what you mean by async race conditions. Are you talking about, because there's two different things. There's data races, which is usually you're trying to read and write to the same location. And then there's just race conditions, which is like a Boolean trap, right? You want it to be true or false, and two things are trying to set it, and you're trying to, you know, and your program stops working because something finished before it was supposed to. That I would just call that a general race condition. Race condition is where concurrency happens and the outcome is inconsistent because of the ordering in which it finishes. Then there's the specificity, which is like a data race. Yeah. Yeah. Joke's old. Come on. How would you ever understand as a beginner why you need the borrow checker and its rules? How would you ever understand that there's any other way to program? Right? Like you're what you're doing to a beginner is you're giving them knowledge they don't have yet. Do it in Rust. You can do that in Rust, right? That is a pointer to a function. Hold on. I think I can read this. Hold on. I think I could read this. My C is not that great. I think I could read this. Okay, so what do we have here? We have what appears to be a function that returns a function that doesn't. Am I saying that right? It's a function that returns a pointer to a function that doesn't return anything. Is that right? I always am so bad on. I'm so bad on these things. The best way to learn something new is to put your existing knowledge at the door. Very true. But anyways, so this article, I think one thing they didn't do well in this article is they're too Rust positive. Like, if you're going to say the dark sides of Rust, I expect you to kind of think about it a little bit more, which is, you know, what is the cost of larger refactors? Does it have the same, you know, like the type system can become a pain to work with sometimes. I think enums, they're fantastic, but they also can be a pain in the ass every now and then. Oh, yes, that's casting. You're right. Oh, my goodness. Oh, I'm such a stupid. Yes, this cast foo to a function. Is that right? This cast foo to a function pointer and executes it? I don't know. Enums are super simple. Enums are super, super simple. They're not hard. But like just go use it for just a moment. But I think that one thing about Rust that makes it super hard is that due to the expressive nature of Rust, it's really easy to express a problem incorrectly. Does that make sense? And so you'll think that you got a good idea, and you'll start going down this path, and you'll express a type that might be nice with what you're doing in the beginning, but as you scale it, it's all incorrect, and you effectively have to redo your types. And so, you know what I mean? Like that it's a hard thought process. I haven't had to do a ton with lifetimes, and so I don't know how hard lifetimes really are. A Rust async is kind of clunky. I agree with that. You know, it's definitely not a W. Well, weird. When I pressed backspace, it wasn't working. Async traits generics is really hard. Absolutely. Impls aren't super used. Like they're super pain in the asses every time I start trying to use more and more impls. So same with other langs. Well, other langs don't have the borrow checker, and so that tends to remove a lot of problems. As far as type systems go, it depends on the expressivity of your types, right? So one thing that goes good at is that types are so simple, you can't create a really complex set of types. And without really complex set of types, you can create, you know, when you need the refactor is very one-dimensional. TypeScript has the same problem, which TypeScript, you can create really complex types, and when you need to refactor, the refactoring becomes much more difficult. Does that make sense? That might be just a pure experience thing that's kind of hard to describe, but I find that the richer the type system is, the easier it is to express problems, but the harder it is to change it. But it's harder to do without good types. Yeah, exactly. So it's a trade-off. I'm not saying one's better. I still don't know if I think one is better than the other. Honestly, like real talk, I don't know which one I think is better. That's why I'm actually super OCaml curious, because when you look at OCaml, it just has a lot less typing and really great inference, and I wonder if that is actually easier to write and refactor. I don't know. Like, I truly don't know, and so that's why I'm just very curious about that. And so I want to take some time and actually learn it and try to, get good at it. Anyways, there you go. That's my thought. Rust of the Dark Side. There you go. Hey, guess what? The name is the Primogen.